The history of space exploration is traditionally told through the lens of the liquid-fueled rocket, yet a forgotten branch of ballistic engineering once proposed a far more radical, industrial, and cost-effective method of reaching the stars: the space cannon. At the absolute epicenter of this unconventional vision was Project Babylon, a gargantuan artillery system designed not for the battlefield, but for the direct orbital delivery of satellites and payloads. Conceived by the brilliant but increasingly isolated Canadian engineer Gerald Bull, this project was the culmination of decades of research into high-altitude ballistics and the physics of extreme muzzle velocity. Bull's central thesis was a direct challenge to the aerospace establishment. He argued that the massive, expensive, and structurally fragile multi-stage rocket was an inherently inefficient solution for launching small, durable payloads into Earth's orbit. Instead, he proposed a fixed-site supergun, a massive steel barrel embedded into the side of a mountain, utilizing multi-stage explosive charges to accelerate a projectile to orbital speeds within a fraction of a second. This was a project that promised to reduce the cost of space access by nearly 90%. Effectively bypassing the entire global reliance on rocket propulsion. However, the sheer scale of Project Babylon pushed the limits of 20th-century metallurgy and chemical engineering to a point of no return, creating a structure so immense that its existence alone threatened the geopolitical equilibrium of the entire world. Before we examine the terrifying internal pressures of this 156-meter steel barrel, please take a moment to hit the like button and subscribe to Never Built. We investigate the sophisticated engineering projects that were abandoned by history. We promise you this: stay with us until the final segment of this series, and you will learn about the transonic vibration theory, the specific metallurgical calculation that revealed how the supergun's own firing sequence would have likely shattered the limestone mountain it was built into, turning the entire project into a self-destructing monument to scientific overreach. The technical foundation of Project Babylon was rooted in the earlier Project HARP, High Altitude Research Project, a joint venture between the United States and Canada in the 1960s. Using modified 16-inch naval guns, Gerald Bull had successfully launched atmospheric probes to altitudes of over 180 kilometers, the highest any gun-launched projectile had ever reached in human history. But Project Babylon was intended to be an order of magnitude larger and more complex. The final design called for a barrel diameter of 1,000 millimeters, exactly 1 meter, and a total length of 156 meters. To construct a tube of this size capable of withstanding the astronomical internal pressures of a launch, Bull had to bypass traditional military manufacturers who were under heavy international scrutiny. He ordered the barrel sections from specialized industrial firms in Europe, claiming they were components for a massive petrochemical pipeline for the Middle East. This pipeline was, in reality, a series of precision-machined steel cylinders, each weighing dozens of tons, designed to be bolted together with a level of accuracy usually reserved for laboratory equipment. The assembly of these components in a remote mountain range required a specialized rail system and custom-built hydraulic cranes, turning a desolate hillside into one of the most sophisticated engineering sites on the planet. The chemical logistics of the multi-stage charge introduced a level of complexity that far exceeded any previous artillery project in the annals of warfare. To achieve orbital velocity without destroying the projectile through sheer G-force, the propellant had to be detonated in a series of perfectly timed stages along the length of the barrel. This required a sophisticated electronic synchronization system that would trigger secondary explosive pockets as the projectile passed them, providing a constant, sustained acceleration rather than a single violent kick at the base. The physics of this traveling wave of pressure were at the absolute frontier of 1990s computer modeling. If the timing was off by even a few milliseconds, the internal pressure would spike instantaneously, causing the massive steel barrel to explode like a pipe bomb of biblical proportions. The heat generated within the barrel during a launch was also a critical failure point. The friction of the projectile moving at several kilometers per second would have melted the interior rifling of any standard military-grade steel. Bull's engineers were forced to develop specialized ceramic composite linings and high-viscosity lubricants just to ensure the barrel could survive more than a single firing. Project Babylon was not merely a gun. It was a 156-meter high-pressure laboratory, a machine that demanded a total mastery of thermodynamics and structural integrity. Furthermore, the structural integrity of the mountain foundation represented the project's most significant environmental and engineering challenge. Unlike a mobile tank or a naval ship, a space cannon is a fixed-site installation that transfers 100% of its recoil energy directly into the Earth. The kinetic energy released during a full-scale launch of Project Babylon would have been equivalent to a localized earthquake. To prevent the barrel from shearing itself off its mountings, it had to be anchored into a massive concrete and steel cradle deep within the limestone strata. This created a permanent, immobile target that was clearly visible from satellite surveillance, a strategic vulnerability that ultimately contributed to the project's sudden and violent downfall. The supergun was a masterpiece of stationary engineering, but it was also a prisoner of its own geography. It required a level of planetary stability and political isolation that the chaotic end of the 20th century could not provide. Project Babylon was a blueprint for a different kind of space age, one built on the brutal, heavy power of industrial artillery rather than the elegant, fragile flight of the rocket. It was a future where the stars were not reached by wings, but by the sheer force of a 1,000-ton explosion. The escalation of Project Babylon from a theoretical concept to a physical structure of steel and concrete introduced the paradox of ballistic friction, a phenomenon that threatened to vaporize the projectile before it even cleared the muzzle. As Gerald Bull's team deepened their calculations for the 156-meter barrel, they realized that the air trapped inside the tube acted as a physical barrier at hypersonic speeds. When the multi-stage charges ignited, the projectile would accelerate so rapidly that it would compress the air in front of it into a wall of superheated plasma. This piston effect meant that the front of the satellite carrier would endure temperatures exceeding 3,000 degrees Celsius while still inside the gun. To solve this, the engineers proposed a vacuum seal system, pumping the entire 1,000-millimeter diameter barrel empty of air before every shot. This required a series of gargantuan industrial vacuum pumps and a fragile mylar seal at the top of the mountain-mounted muzzle. The supergun was no longer just a piece of artillery. It had become a complex vacuum chamber where a single microscopic leak in the 150-meter steel skin would lead to a catastrophic pressure imbalance that could implode the barrel during the ignition sequence. The mechanical harmonic distortion of the barrel sections represented the project's most persistent engineering nightmare. Because the gun was composed of multiple segments bolted together, each joint was a potential point of failure. At the moment of firing, the shockwave traveling through the steel would move faster than the projectile itself. This created a harmonic whip effect, where the 150-meter tube would begin to vibrate and flex like a tuning fork. If these vibrations reached a resonance frequency, the steel would lose its structural integrity, causing the bolts to shear off and the segments to disconnect in mid-fire. To counter this, Bull designed a massive external support skeleton, a series of hydraulic dampeners and tension cables that wrapped around the barrel like the tendons of a giant. This turned the hillside into a labyrinth of steel rigging, making the project look less like a weapon and more like a futuristic industrial cathedral. The internal tolerances were so tight that a misalignment of even 2 millimeters between the segments would cause the projectile to strike the inner wall, resulting in a kinetic energy release equivalent to a tactical nuclear strike. Furthermore, the logistical deception of the petrochemical supply chain added a layer of psychological tension to the engineering site. To acquire the high-strength steel required for the 1,000-millimeter barrel, Bull's front companies had to convince European manufacturers that they were building a revolutionary heat-resistant pipeline. The engineers on site lived in a state of constant paranoia, working under the guise of civilian contractors while assembling a machine that they knew could alter the balance of global power. The site was shrouded in camouflage netting and surrounded by high-intensity security, but the sheer scale of the construction made it impossible to hide from foreign intelligence. Every day, the workers would look up at the mountain and see the gargantuan steel throat of the gun growing longer, knowing that they were building a sky piercer that the world was not yet ready to accept. The project was suffering from strategic visibility. It was an engineering feat so large that its very shadow served as a warning to every neighboring nation, turning a scientific endeavor into a countdown for a geopolitical confrontation. The internal ballistic synchronization was governed by a primitive but powerful 1980s computer system that acted as the brain of the gun. This system had to manage the ignition of hundreds of secondary charges with microsecond precision. If a single charge fired too early, it would create a back pressure wave that would collide with the projectile, shattering the delicate satellite inside. If it fired too late, the pressure would drop, and the projectile would fall short of orbital velocity, crashing back to Earth as a multi-ton kinetic bomb. The engineers were essentially trying to perform a controlled explosion that lasted several seconds, a feat that challenged the fundamental laws of fluid dynamics. They were operating in the transonic danger zone, where the air and gases inside the barrel behaved in unpredictable, non-linear ways. Every test firing of the smaller 350mm prototype provided data that suggested the full-scale 1000mm version was pushing the materials to their absolute molecular limits. The steel was being asked to contain pressures that were usually only found in the depths of the ocean or the cores of stars. Moreover, the acoustic impact of the launch was a factor that the local geography could barely sustain. A full-scale firing of Project Babylon would produce a sonic boom so powerful it could shatter windows and collapse structures for tens of kilometers. The roar of the expanding gases exiting the muzzle at the top of the mountain would be audible across international borders, serving as an unmistakable signal that the space cannon had been awakened. To mitigate this, Bull's team explored the use of acoustic dampening trenches dug into the mountainside. But the physics of such a massive sound wave were nearly impossible to dampen. The project was a physical manifestation of industrial hubris, a machine so powerful that its mere operation would be an act of environmental and political aggression. The supergun was a masterpiece of 20th century ambition, but it was being built on a foundation of secrets and high-pressure steel that was destined to crack under the weight of its own impossible goals. The transformation of Project Babylon from a scientific experiment into a perceived weapon of mass destruction was triggered by the calculated trajectory of terror. While Gerald Bull publicly maintained that the supergun was an orbital launch vehicle, military analysts across the globe saw a much darker potential. They realized that a gun capable of firing a satellite into space could, with a simple adjustment of the elevation and a change in the projectile's weight, strike any city on the planet within minutes. Unlike a ballistic missile, which can be detected by radar during its long, arcing flight, a supergun projectile travels at such immense speeds and with such a low radar cross-section that it is effectively invisible and unstoppable. This was the birth of the Ghost Strike capability. Project Babylon wasn't just a ladder to the stars, it was a 156-meter sniper rifle aimed at the heart of the world's capitals. The massive steel barrel became a symbol of a strategic threat that no existing defense system could counter, turning the scientific dream of cheap space access into a geopolitical nightmare of total vulnerability. At the core of the project's technical downfall was the harmonic resonance catastrophe, a phenomenon the engineers called the deadly vibration. As the barrel reached its full 156-meter length, the sheer physics of its mass began to create a dangerous feedback loop. During high-velocity test fires of the smaller 350mm prototypes, the shock waves traveling through the steel segments didn't just dissipate. They reflected back from the muzzle and collided with the following pressure waves from the secondary charges. This created a standing wave of energy that began to warp the molecular structure of the high-tensile steel. The internal lining of the barrel, meant to be perfectly smooth, started to develop microscopic ripples. If a projectile hit one of these ripples at 6 times the speed of sound, the resulting friction would create a localized heat spike intense enough to trigger a premature detonation of the projectile's own explosive payload while still inside the mountain. The supergun was effectively becoming a 150-meter fuse for a self-inflicted disaster, a machine that was vibrating itself into a state of permanent instability. Furthermore, the sovereignty of the mountain base became a prison for the project's ambition. Because the gun was literally bolted into a limestone range, it could not be hidden, and it could not be moved. This created the fixed-point vulnerability, a flaw that Gerald Bull, in his technical brilliance, had fatally underestimated. Modern warfare is defined by mobility and stealth, but Project Babylon was the exact opposite. A gargantuan, immobile landmark that could be seen from low Earth orbit. Intelligence agencies from at least 5 different nations were tracking every shipment of pipeline segments that arrived at the site. The secrecy that Bull had tried to maintain through complex shell companies was evaporated by the sheer physical reality of the construction. The world's superpowers realized that they didn't need to engage in a complex arms race to counter the supergun. They simply needed to ensure that the project never reached its final assembly. The mountain, which was supposed to protect the gun from recoil, had instead become a tomb that marked its exact coordinates for destruction. The chemical volatility of the propellant storage added a layer of immediate danger to the site that the blueprints had failed to address. To power a single orbital launch, the project required hundreds of tons of specialized multi-stage explosives stored in high-pressure bunkers dug into the surrounding rock. The environmental heat of the Middle Eastern desert made these compounds increasingly unstable. The site was effectively sitting on a powder keg of unprecedented proportions. If the supergun ever suffered a catastrophic failure during firing, a muzzle burst, the resulting explosion could trigger a chain reaction in the storage bunkers, potentially leveling the entire mountain range and releasing toxic chemical plumes that would drift across international borders. Project Babylon had become an environmental time bomb, where a single engineering error or a stray piece of shrapnel could result in a disaster that transcended the battlefield. The risk-to-reward ratio was collapsing. The dream of cheap satellites was being outweighed by the threat of a localized apocalypse. Moreover, the assassination of the architect in March 1990 served as the final, violent proof that the world would not allow Project Babylon to exist. Gerald Bull was found dead outside his apartment in Brussels, a victim of professional assassins whose identities remain a subject of intense speculation to this day. Without his obsessive leadership and his unique understanding of the traveling wave ignition sequences, the project was paralyzed. The engineers on site in the mountains found themselves in charge of a 156-meter steel corpse. The sophisticated computer systems that managed the firing synchronization were locked, and the specialized lubricants required to protect the barrel were seized at international borders. The project was suffering from intellectual decapitation. It was a machine too complex to be finished by anyone other than its creator. The supergun stood silent, a gargantuan steel skeleton half buried in the limestone, waiting for a command that would never come. The physical death of Project Babylon was as dramatic and high stakes as its conception. Following the assassination of Gerald Bull, the international community moved with surgical precision to dismantle the supergun before it could ever breathe fire into the upper atmosphere. In what became known as the Pipe Affair, customs officials in Britain and Greece began seizing massive steel cylinders labeled as petrochemical parts, but which were actually the final segments of the 1,000-millimeter barrel, The world watched in shock as the sheer scale of the deception was laid bare on the evening news. These weren't just pipes, they were precision-engineered components of a machine designed to defy the gravitational pull of the Earth. After the 1991 Gulf War, UN inspectors entered the secret mountain site and discovered the half-finished 156-meter Titan. Under strict international supervision, the Babylon was cut into pieces with thermal torches, its high-tensile steel reduced to scrap metal. The dream of an orbital cannon was officially executed, its blueprints buried in classified archives, and its physical remains scattered across the desert. The scientific autopsy of the project's failure revealed that even if Bull had survived, Project Babylon faced a thermal wall that 1990s materials science was likely unable to scale. Modern thermodynamic modeling suggests that the friction of a satellite-carrying projectile moving at Mach 7 through a 156-meter tube would have generated a plasma compression wave that could have compromised the structural integrity of any payload, no matter how reinforced. The electronics inside the satellite would have had to endure G-forces exceeding 10,000 Gs, a level of acceleration that would turn most modern silicon chips into dust. Project Babylon was suffering from the acceleration gap. While we could build a gun large enough to shoot into space, we couldn't build a satellite tough enough to survive the shot. The project was an engineering masterpiece that existed in a vacuum of utility, a solution for a problem that the payload technology of the time wasn't ready to solve. The legacy of the ballistic shortcut continues to haunt the aerospace industry as the cost of rocket launches remains a primary barrier to space colonization. The space cannon concept didn't die with Project Babylon. It merely evolved into the electromagnetic railgun and the centrifugal launch system. Today, companies like Spin Launch are using the same principles Gerald Bull pioneered, substituting chemical explosives for kinetic and electric energy to throw satellites into the sky. We are finally building the vacuum chambers and the high-G electronics that Bull envisioned in the 1980s. Project Babylon was the ancestral prototype of a future where we no longer rely on expensive, explosive rockets, but on the pure, raw power of kinetic acceleration. Gerald Bull's 156-meter steel ghost still whispers to modern engineers that the shortest distance to the stars isn't a slow climb on a pillar of fire, but a sudden, violent leap from a barrel of steel. The geopolitical lesson of the supergun remains a stark reminder that technology is never neutral. Project Babylon proved that a scientific breakthrough in the wrong place at the wrong time is indistinguishable from a declaration of war. It was a project that failed because it tried to be too many things at once: a scientific tool, a military deterrent, and a secret industrial operation. The supergun was a machine that required total trust in a world defined by total suspicion. By building a gun that could reach the stars, Gerald Bull inadvertently built a target that his project could not survive. It remains the ultimate canceled future, a $500 million monument to the idea that some paths to the heavens are too dangerous for the Earth to allow. Project Babylon stands as the most ambitious and controversial engineering feat of the late 20th century. A 156-meter steel throat that almost screamed at the stars. It was a project that challenged the hegemony of the rocket and paid the ultimate price for its defiance. Today, the limestone mountains where the gun was built are silent, the concrete cradles empty, but the blueprints remain a haunting what if in the history of human reach. The space cannon was never built to its full scale because the world realized that a gun that can shoot into space is also a gun that can bring heaven down to Earth. The final question for you is this: as space travel becomes more commercialized, will we see the return of the giant orbital cannon as a cost-cutting necessity? Do you believe that Gerald Bull was a visionary who was silenced by the status quo, or was he a dangerous architect of a weapon that could have triggered a global catastrophe? Let us know your thoughts in the comments and tell us. If a space cannon could reduce the cost of reaching orbit by 90%, Would you support its construction today, even with the military risks involved? If you found this deep dive into the 156-meter supergun and the tragic history of Project Babylon fascinating, like this video and subscribe to the channel. We are uncovering the sophisticated engineering and the lost futures of the projects that were never built.